So as Sean mentioned, my background is in cognitive science. So I'm really interested in doing experiments in terms of understanding how people learn. And to get a sense of where that fits in with the sort of research landscape, because there's a ton of great research on learning and many insights. I guess the way I split it up is thinking in terms of qualitative analyses. So these are kind of rich investigations that you see from a sort of sociological perspective, education schools that will take a student and really take a very close look at what they're learning, explore their understanding of algebra and all the different misconceptions they can have. Then there's also things that are much more like randomized controlled trials. So policy work where you might take one bunch of students in a school and give them a treatment where they undergo a training program, and then you can see if that actually has an effect compared to a control group. And that's at a very kind of large scale. There's longitudinal studies, which again, are a very long time scale, collecting measures like people's grades or students' sort of outcomes as they progress through traditional education. And of course, there's work in computer science and educational data mining, where you take very large data sets with some observations and try and induce what's going on with learners. And so in terms of where cognitive science fits in with this, I think it's sort of in between something like a randomized controlled trial longitudinal study and something like qualitative analysis, because most of the experiments we do on a sort of short time scale, and it really involves sort of precisely controlling what someone's learning in a particular situation and trying out different forms of instruction and then assessing how learning is occurring after that. And you might think that from such sort of micro experiments you can't learn much, but that's actually sort of one of the the expertise in cognitive science. And I think it's really insightful. It's obviously used a lot of insights, but I think it's really well suited for online education, where often you want to ask questions that kind of intermediate between sort of getting a qualitative assessment of what's going on and running a full-out randomized controlled trial where you give people two different versions of the course. There are questions about how you should frame instruction, what kind of video you should show someone, the kind of strategies you should teach them. And so just let you kind of know where it sits in there. And what's also nice about cognitive science as an approach is it's pretty interdisciplinary. In the sense you've got psychology, which is heavily focused on experiments, philosophy in terms of really trying to do good conceptual analysis of what problem you're facing and classifying different kinds of learning, linguistics, anthropology, as I mentioned, neuroscience, and of course, AI. And what's also nice, I think, is that it's also a bit easier for people in cognitive science perhaps to talk with the kind of researchers at Google who are really interested in often things like modeling and machine learning. Okay, so to give you a bit of a preview of what I was planning to cover. So I'm going to talk about two ways you could think about learning. One that I think sort of gives us a lot of rich insights into how to improve education. And I'm going to talk about, very quickly, three findings in cognitive science that I find have been particularly powerful. It's sort of thinking about what can you do before someone starts learning in terms of framing their learning as an answer to a problem. What can you do during learning in terms of requesting explanations from the learner? And then what can you do after learning? And the really interesting finding here is that you can actually use assessments as instructional tools. Having people take a test can actually be more powerful for learning than having them study material again. And then having sort of looked at some of what we know about how to promote learning of a concept or some set of knowledge, it's kind of worth asking, well, what knowledge can we teach someone that's actually going to have the biggest impact practically? And that's why I think thinking about this idea of what do people learn that's going to help them learn more. So it's not just on this concept, but across a range of situations. And there, I'll talk about how you can change people's beliefs and have a massive effect on their motivation. You can teach people strategies for learning that then influence, have trickle-down effects on all the content they may come across. And then finally, I'm going to talk about online search, which is something I've really started to think about seriously recently since looking at the Google Power Searching course. And I actually think this is a sort of really fascinating topic that's right at the junction of things that are really important to industry and the business world, and also really important to education. And I think that's actually a great sort of place to focus because it allows you to get the benefits of sort of private innovation as well as academic work. And also it means that you can sort of use insights across areas. When you're sort of teaching a business person about search, you're also learning something about how you could help a child to be more inventive in the way they discover information on the internet. How is my speed in terms of talking? Because with an accent, it probably sounds like twice as fast, and I speak twice as fast, so you're hitting a lot of powers being raised there. Okay. And one thing I'll cover at the end is I put on the website just a list of resources that I found really useful in terms of knowing what the literature is that has shown really good, impressive effects on learning. When you go on Google Scholar, I mean, literally there are thousands of papers there. And I think that can be daunting, and it's easy to sort of think that it's just easy to sort of start with your problem and work on that. But there's always tons of really interesting, relevant work. And so I've tried to put aside some of the resources that I found most useful. So I have hyperlink links to some of the papers there and brief explanations of what they're about. And also information about other things I'll talk about at the end. Okay, so in terms of learning, I think one kind of challenge, even after studying learning for so much, well, all my adult life, I still think that there's this kind of intuition or this intuitive theory that I have about learning that sort of holds me back or kind of misleads me when I'm making instructional decisions. I think it's something that's sort of common across many of us. In the sort of Cambridge Handbook of Learning Sciences, they kind of refer to it as the idea that when you learn something, you're just sort of dropping it into a bucket. You're sort of just learning as transfer from the teacher to the student. So let's think about some content. For example, learning from a video, like from a power searching online video or Khan Academy video, or reading text, which is how we absorb most of our information. Or you could think about learning from an exercise. So a student solving a math problem, or someone attempting to process a financial statement, or do some budgeting, or solving a problem of managing relationships with coworkers. Anytime you kind of see those icons, I mean to represent, you can sort of stick your personal content in there. So if you have a favorite example of learning or one that's particularly relevant to your everyday experience or your job, just feel free to insert that every time that flashes out. But I'll try to illustrate it with examples. Because again, there's good evidence that that's an important thing to do for learning. So I think there's this intuition that what learning is about is just adding information. So it's almost as if we have this model where the mind is a bucket. And so what does it mean to learn? Well, it means to take information and drop it in that bucket. Whether it's videos, text, solving stuff, just put it in. And later on you can come back and get it. But actually, I think a much better way of thinking about learning is that it's like taking a piece of information, integrating it into the internet in the same way you'd add a web page. So that galaxy is the internet, and you can guess what those big giant planets are. So how might you think about this analogy shedding more light on learning? Well, under this kind of view, when you're adding content to the internet, there's actually, first of all, you have to think about 3 stages. Well, what do you do before the content arrives? Or what do you do in sort of linking it to what's already known? So it's really important now, you're not just dropping in a bucket, you're actually linking it to web pages that already exist by citing them. You're putting on a particular domain. And so I think this is very analogous to the sort of challenge we face as learners of how do you get information to link up to what people already know? And in what kind of knowledge are you linking new concepts to? And I think it's something that's obvious when we look at it, but it's definitely not at the forefront, I think, of a lot of instructional decisions. Also, if we think now, even sort of processes people engage in while they're learning. Everyone on the internet, time is limited. They're not going to read your whole web page. If you're lucky, they will even read the first few lines. So you have to ask questions like, how do you structure the information on a web page so that the really core concepts jump out? What are the key principles? Or depending on the person, is the web page structured so they can get the information they need? And so this is analogous to when we're processing something like a video or a lesson, a bunch of text. It's actually just flat out impossible to remember all that information. So what are the kind of cognitive operations you're engaging in that pick out some information as being more important than others? Sort of some relationships or some principles or some details of whatever content you're learning. And then finally, what's the last part of getting a web page off of the internet? Again, I think you guys all have a bit of an advantage in answering these audience participation questions, but it's actually being able to find it. And this is probably the most underlooked part of understanding how we sort of retrieve, what learning involves. Because anytime you learn something, it's only going to be learning if it influences your mind in a way that at some point in the future, you're going to act differently because of it. So you have to retrieve that information in some way. So for example, learning is the final stage of learning is, it's got to sort of be set up in a way that it's got the right cues or the right connections, that when someone goes looking for that information, they're actually going to find it. For example, I might learn really interesting things about mathematics from a video. And you could say that I know it, but when I'm actually faced with a situation where I have to solve or differentiate something, am I actually going to remember that fact at that moment? Or am I going to remember something else I learned about differentiation or something else about functions? And so really a key challenge in learning is that instruction has to actually ensure that people are putting information in the right way, that they can access it later. And actually a key part of that is going to be that after instruction takes place, it's actually really important to give people practice in testing them and sort of accessing that information. What could be called like retrieval practice. Okay, so one thing I wanted to sort of really hammer home on this point in terms of why it's really important to think about how hard learning is and why these two models kind of matter is that there's this phenomenon called transfer, or this distinction, which is that learning might just be getting a piece of information, but transfer is when you take an abstract principle from one context and use it in another one. So transfer is extremely rare. And I think this is probably the biggest, most important thing I feel like I know now that I didn't know 8 years ago, is that I assume that if I'm told something and I don't remember it, well, I just forgot it, I have to practice a bit more. But actually, it's a much more profound problem than that. Almost nothing, I mean, some people make this statement that almost nothing that we learn in one context is going to get transferred to a very different context. And so actually, the way we do most of our learning is by really learning things in very specific contexts and slowly generalizing them out. So for example, let's sort of think of a problem. Let's say that you're a general trying to invade a castle, and you've got 100,000 people, and you know that you can take it if you send them all at the same time. Unfortunately, the person in the castle knows that as well, and they've mined the road so you can only send 20,000 at a time. So that's just not enough. You can't send 20,000 people to fail to take the castle. So how do you solve this problem? You need 100,000 to arrive at the castle, but you can only send 20,000 along any single road at a time. Okay. Yeah, there are multiple roads. So the idea is that you divide this up, you divide your force up, and they go and sort of do it. Here's a separate problem. It's going to use a different kind of technique. You're a physician, and you need to kill a tumor in someone's stomach. And you've got really high-frequency rays that can destroy the tumor, but it's also going to take out a large part of the person's flesh. And you've got low-frequency rays, but they're not actually going to kill the flesh or the tumor. How do you solve that problem? Yeah. So here I sort of like give you guys an advantage. But what's shocking is that if you have people, you can bring someone right in front of you. They'll do the problem, turn the page, do the next problem. 20% of people will actually transfer that spontaneously. You could even help them, get them to elaborate the principle, do all kinds of things when they're learning their first problem. They don't tend to transfer it spontaneously. If you tell them, I think the one before is relevant, then they might stop and really think, and they're like, oh yes, I see how to solve it. But that kind of transfer, you obviously can't have someone running around like telling you what's relevant to what. So it's sort of, I think it really, in my mind, highlights something that seems so obvious, like the common principle there. It does not happen for people at all. It just doesn't come across. It's almost like they learn something about generals and invasion, and they learn something about medical practice. They didn't learn that abstract principle, and it's really tough to get people to. In fact, I could give you guys similar versions of this problem embedded in your life, like in a week, in a few weeks, and you'd be surprised how high a rate you'd fail at that. They've even done really compelling studies where they take business students and they have them learn a negotiation strategy. For example, we all think negotiation is about compromise, but actually one much better strategy is to find out what the other person wants that you don't really care about, and what you want that they don't really care about, and trade off on that. So we could have an orange, and if we're fighting, you could take half, I could take half, but maybe I want the peel because I have to flavor up some food, and you actually want the inside because you're hungry. That's a sort of a trade-off negotiation strategy. So what's interesting is when they take MBA students and teach them this strategy, they sort of do everything that you want your students to do. They understand the strategy, they can explain it to you, they can give you other examples of the strategy, they really get it, except when they actually have to use it. If you put them in a face-to-face negotiation, they fail to use the strategy. So that's sort of really compelling because even in a situation where someone's done everything that we'd like students to do, and students almost never get there all of the time, it's still the case that they're going to fail to transfer. And so I think that really highlights sort of the importance of thinking carefully about what sort of processes you have people engage in while they're learning, and also having assessments that can really help you understand if people have transferred or not. Oh, sorry, yeah, I'll clarify. So they could tell the strategy to you, and they could write out and explain the principle, But if like 2 minutes later, they were then in a situation where they had to negotiate with someone, like face to face, as part of a team, they would, I mean, there were 20 to 30% would do it. 20 or 30, but it was very low. Yeah. Exactly. And it's shocking because they really did understand the strategy, but face to face, it was just, it's almost like you have a different set of concepts when you're dealing with people and different set of concepts when you're learning something in your class. Yeah. I guess I would actually, it's probably both are true, but I'd say I'd lean towards the second one. That it's almost, I mean, the way some people write about it, your mind is not designed for transfer. It's not designed. You've got concrete concepts that correspond to different things, and if you want transfer, you have to do something special with them. Actually, that's the original paper that showed the general and the medical study. This is one that showed it with business students, and actually this guy wrote a book that's sort of called Transfer on Trial, where he pretty much argues he thinks transfer almost never occurs, and so what we need to do is teach people specific skills in specific contexts. Obviously that's an extreme position, but that's just to let you know the tone of how people think about this. Yeah. Oh, sure. The question was, are these failures of transfer also true if while they're learning about the concept, they do mock negotiations? And so, or if the other point was maybe if they do 3 different negotiations across different contexts. And so those things definitely help and they make a big difference. The sort of really key principle that I've seen is that there's a big focus in business and medical education on case-based reasoning. And so, and actually, you know, there's good evidence that helping people structure abstract concepts around a specific case is really useful. But the experiment by Gentner, Lowenstein, and Thompson, what they sort of showed is that even if it helps to have a specific case, you still don't necessarily get the abstract principle. So what was really nice about the experiment is they would give people 2 cases, one after the other, as was suggested, versus give them the 2 cases side by side and actually tell people what are the similarities and differences between these 2 cases. In this story about, I mean, it was about business, but let's say story about general, this story about the medical doctor, which agents are playing what role and what's the relationship that exists here. And so when you actually do that sort of pretty extensive process, which is really good at helping people really like get abstractions in a way that telling it to them in words just doesn't. When they actually have to process this and align items, that actually makes a big difference in abstraction. But it's not necessarily enough for them to just see cases. That helps, but you've really got to add something extra onto it. And comparison is sort of, I would say, one of these super processes that we've seen for getting people to really grasp an abstract concept that they won't get in words or they won't get just from examples. Okay. So in terms of thinking about if someone's about to learn some content, what are things that we can do before? So they can watch a video about some training they have at work, or they can read a text about mathematics. So what we typically do is give them that information. And you know, we might ask 1 or 2 questions or tell them what they're going to study. You're going to learn about math. But pretty much you give them the information, almost very much in line with putting it into their head like it's a bucket. But actually, there's this really interesting set of work on what's called problem-based learning. And so the idea here is that with a very minimal change, you can influence how people are going to process that video or lesson by asking them a question before that's going to make them interpret everything they learn as a solution to a problem. So instead of learning, for example, reading a bunch of text about solving algebra equations, if that was prefaced with, if you have 2 variables in an equation and you're trying to figure out how to isolate one, how would you do it? The student will probably not actually know how to do that. They'll fail. They'll try all kinds of things that are wrong. But the mere fact that you sort of got them thinking about that problem then means that as they go through the lesson, they're sort of encoding all that information as a solution to that problem. For example, you can think of cases where people have sort of told you something and you sort of take it for granted or encode it. But if you'd first been trying to solve a problem and then gotten that piece of information in response, that would have been much more effective for learning. And so what's really nice about this manipulation is that it's very minimal in that all you've got to do is take whatever content you have and proceed it with some questions. For example, if you're about to learn, let's say, about power search, you could ask someone, well, how do you find this kind of content? Or if you're learning mathematics, is it possible to construct this kind of relation? And then just having people think about that will then lead them to sort of process everything they see after differently. It's also more motivating for students in that they're sort of not just absorbing facts, but they feel like they're actually learning with some kind of purpose in mind. So in terms of thinking about what you can do during learning, and here I'm going to focus on work I've done on explanation just because it's what I know best in terms of presenting. So the idea here is that we all have this intuition that, it's really good if we actively process information. Or if we've ever tried to explain a concept to someone else, something about actually explaining to them might have taught us something new. But despite that, it's not so often that instructional videos or texts have sort of questions embedded in them or activities that force you to sort of generate explanations. And so there's a good bit of evidence that this does actually help learning. If you can sort of prompt someone as they're learning to generate explanations, they sort of understand it more deeply and they're more likely to transfer the principles to another situation. But the question I was interested in is understanding, well, not to be too meta about it, but why is it that explaining why helps you learn? And this is really relevant in terms of thinking, when are you going to ask learners for explanations? You can't ask someone all the time. Or is there a certain kind of content you should ask for? Or what kind of knowledge is going to be targeted when you ask for an explanation? So it's got really important practical implications in that sense. So again, I would contrast just throwing someone into learning and letting them sort of use whatever strategies come to them with actually prompting them while they're learning to explain why they're doing something, to explain why a fact is true instead of just accepting it. And so we looked at this in three contexts. The first was in terms of learning artificial categories. So even though there's lots of work on explanation in rich educational settings, this is the first study that's actually in a lab context with artificial materials, where you can really control things very precisely. Even if we have a sense that explaining is helping, it's very hard to pin down exactly what kind of knowledge people are gaining. Is it just that explaining is making people pay more attention? So the mere fact that you have to answer a question means that you've got to pay attention to what you're learning instead of dozing off or looking at other information. You've got to spend more time processing it. It could also be that because you have to provide an explanation, you're more motivated. There's this kind of social context where you have to produce information that could possibly be relevant to someone else. And so if those are how explaining works, then that suggests one way in which we could use it as an instructional tool. But the idea that we want to test is actually that explaining's effect is a lot more selective. That there's something about explanation that doesn't just boost your general processing or attention, but actually is sort of constraining you or forcing you to search for underlying principles or patterns, for generalizations. And so this is a question we could test more readily when we look at a constrained context, like learning artificial categories. We also examined explaining people's behavior. So for example, if you notice a friend donates to charity, that wasn't me, right? Okay, that's fine. If you notice a friend donates to charity, you could just encode this fact about them. You might sort of make other predictions from it, like they're going to have less money in their pockets at the end of the day and probably won't treat you for drinks. Or you could try and explain it. Well, why did that person give to charity? And again, that's a different way of learning about another person. And so as effects just to boost your general attention to what they're doing, or is it actually going to do something deeper, like make you search for an underlying principle? And the final context that we looked at this in was actually trying to learn something more educational. So the idea here was that we had people learn a bit about the concept of variability. And this is the example I'm actually going to talk about in depth so that I don't spend too much time on this part, but I'll sum up the main conclusions. Across all of these domains, the basic form was for different materials and different kind of knowledge, but the basic form was asking a why question, explaining category membership, explaining why someone did something, or explaining the solution to a problem. And that would be contrasted with letting people sort of choose their own strategies, so being able to sort of study freely. And we also contrasted with asking people to say out loud what they were thinking. Because it could be that the main effects of explanation are actually having you clarify your thoughts. Once you sort of state it explicitly, you can see what you were thinking, what was missing, what the gaps in knowledge were. And so we're sort of trying to pick apart that effect from whether there's something else we're explaining driving you to search for underlying principles. And then following study, we gave people learning measures that tapped exactly what they'd learned. Okay, so to talk about going into that third one in more depth, I'll just run through the procedures so you can get a sense. So the idea here is that people have to learn a university's ranking system from examples. So you're told that a university has a way of ranking students from different classes, and you're going to see examples of students who have been ranked by last year's officer, and you have to learn, well, what's his system for doing it? What information are they using? So for example, you've got information about someone like their personal score, their class average, the class minimum score, the class deviation. So for example, this might be John. He got an 86% in history. You might see what the top score is, what the class mean standard deviation is. Then there's another student. Then physics, they got about 82%. Again, you see the top score, the class mean, the class standard deviation. And so you'd actually be told which one is ranked higher. So for example, you'd be told the person on the left was. And so now trying to think about how you could learn about this, there are a bunch of different ways you could approach it. You could sort of pay attention to lots of examples, and then that would inform future situations. You kind of automatically get an intuition for how people are ranked. You could try and look for different patterns. So for example, maybe people are ranked higher just if they get a higher score. The university is pretty egalitarian across courses. You could think it's actually how far they're above the class average. So for example, this person's 6% above the class average, whereas this person's 4%. So even though they got a much lower score, they might still actually be ranked higher. Actually, sorry, this is consistent in this case, but it isn't actually, the reason this person's ranked higher is not because they got a higher score, it's actually because they're farther from the average. You could also think it's actually just a matter of being close to the maximum score. If you're close to the top person, then you deserve to be ranked highly no matter what. And then finally, if you think about what statistics would suggest, there's this idea that you should actually look at the distance from the average, but weight it by whatever the standard deviation is. And so the idea here is that what you really want to know is how far above most of the other students in the class was each of these people. And that'll give you a measure of whether you should rank someone highly or not. How many standard deviations above were there? What was the z-score? And so we gave students a bunch of these observations. They sort of saw 5 ranked pairs in total. And the actual true rule was using the number of standard deviations someone was above the average. But the other rules were pretty salient, and in pre-testing, we find that a lot of students endorsed them. Whoever got the highest score should be ranked higher, whoever's closest to the maximum, and so on. And so some of the observations just didn't fit with those rules. So this might fit sometimes with the higher raw score, but sometimes they don't. They might match the close to maximum rule, but not always. And so the idea here was, if explaining really forces people to seek underlying principles, then explaining these sort of observations and the ones that sort of conflicted with some rules versus others should drive them to actually find this underlying principle, the sort of rule about deviation that actually applies to all the observations. And so this is what we found. This is showing you people's accuracy in classifying ranked pairs before and after and how much improved. And what you see is that people who had to explain had a much bigger increase in accuracy, about 40%, compared to those who were writing their thoughts. And it's interesting because writing your thoughts is a pretty elaborative activity. You know, you have to express what you're thinking about the materials, you have to process them deeply. But explaining still drove people to find this broader principle. And that's just an illustration because across all those contexts, whether it was learning about categories, explaining how people find a broad generalization that counts as category membership for all the robots. If it was explaining people's behavior, again, you were more likely to discover like a general pattern, like young people donated to charities more often than older people. So this suggests that in terms of thinking about educational context, when you want to ask someone a why question, it's not necessarily a good idea to just always be prompting them or just trying to boost their engagement. You actually want to be selective in terms of when they're sort of given examples that can point them towards an underlying principle, then you need to prompt them to explain why. Or if you think they don't have enough knowledge to induce a principle yet, then it might actually make more sense to engage in other activities like helping them acquire new concepts or have more facility with understanding how different, understanding what the different facts are. And then they might reach a stage where they can actually, with prompting, be able to induce the underlying principle. What's another interesting thing is that in the second line of experiments, we found that explaining actually boosted the extent to which people use their knowledge in finding online principles. So the idea was that in the absence of explaining, you might have a lot of relevant knowledge that might suggest that deviation is a good rule or something else is, but you don't actually bring it to bear. If you explain, though, and you don't have that knowledge, well, then you might find some pattern, but it's not necessarily the correct one. So the idea is that explaining and prior knowledge interact to guide what patterns people are searching for and what they like to detect. You mean in general or with respect to? So we ran it online and we just asked people afterwards how familiar they were. And there was a pretty big range. Some people had never heard of it before, but a decent number had at least come across the concept before. In those people, though, they still did really badly on the pretest. So, I mean, in a lot of sort of experimental situations, you can sort of look at interesting effects of learning because the truth is that learning just doesn't really occur that well the first time around. So often they're sort of relearning the material. And even with extensive practice, it's kind of hard to get people to get that idea of the Z-score principle. And we didn't find differences between low and high, people who had low and high exposure. But again, that might be because we need to broaden the sample. Because it was online, we might just have gone people who weren't, who just didn't have a lot of knowledge. They wouldn't sign up for a math experiment, maybe. Also, in terms of thinking about explanation's effect, it really was selective. And actually, what we found is that it didn't help you remember information better. Sometimes even impaired it. But especially if there wasn't a reliable pattern present, or if you couldn't actually find it because you just didn't have enough knowledge to, explaining actually impaired learning in some cases. Because it drove people to keep searching for a principle that didn't exist, or one that was only partially reliable. And so this is something you might think about in terms of when people sort of make these like mini generalizations, or they make these kind of bugs that sort of seem half right. Children do this a lot in algebra, for example. And it might actually be from trying to seek explanations and construct some kind of pattern. But it's just a case that that's not actually going to it's characterized as cases they've seen so far, but it's not actually going to help them with future learning. And so again, that's another reason to think about carefully about, well, when are you going to prompt someone for an explanation? You need to do it at a point where it's not going to hinder their learning or be worse. On the flip side, it's not saying explanation is bad, it's just saying it's sort of like a powerful selective tool that if you use in the wrong cases will actually be harmful. And then, since most of the work was with adults, we also looked at the effects of explanation in 5-year-olds learning causal relationships, and we found very similar results. Even though they were young and their ability to verbalize are pretty limited, they were still able to, when prompted to explain, discover underlying patterns, and especially to bring prior knowledge to bear and actually use it to discover patterns that they wouldn't if they weren't explaining. Now, in terms of thinking how to take these kinds of findings online, one really good context is thinking about things like online mathematics exercises, like the one that Khan Academy has in their framework. So that's sort of a mini shrunken version, but basically people will get a problem statement and they like sort of try and solve it and type in an answer. And along the way, if they want hints, clicking on a hint button gradually exposes the actual solution. And so in the literature, this is called a worked example. And it's sort of infamous that sometimes they can be much better for students learning than just trying things out and not succeeding. But it's really hard to get people to process them deeply, to actually not just skim over it, but sort of understand each component, each step, and how it relates to something more general. You sort of get the principle. And so that's one case of explaining could be really helpful. And so there are a number of different ways we're thinking of approaching this, but the basic or the simplest version is something like when someone enters a correct answer, even if they're sort of following a solution, you can prompt them to try and think, well, explain why that solution is correct, or explain why that person took the step they did. And even though it seems, of course, you just saw the correct answer, you should be thinking about why it's correct. This is actually not necessarily that common. It's not guaranteed. A lot of students may be trying to memorize the answer. They may be trying to explain other aspects of the solution. There are sort of many things that people may be doing. And when you do sort of detailed analyses of children's strategies, you find incredible variation. And so that idea of just having that prompt could sort of focus them on sort of understanding how that particular answer, that particular solution is just an instance of a general principle. What's the sort of general strategy that was used here? What's the key concept? Now, one thing that could be problematic is, even though this is promising because you can get people to learn, just by being prompted, so you don't necessarily have to give them feedback. When people don't get feedback, they often tend to sort of feel like they're throwing explanations into the void. They're just talking and it's disappearing. And so one thing I'm going to try is try and couple this really closely with actually giving them an explanation, a correct one, or almost correct one, and tell them there's another student or teacher's explanation. And so the idea is now we've changed the task from do something that the teacher or instructor is asking you to do, type something in, to generate an explanation, and then you're going to be comparing it to what someone else said. And so the idea here is that at this point you could ask them to do things like, once they've got an explanation written down and they see someone else's, well, what if you grade both of them? Do you think that was a good one on a scale from 1 to 10? Was the new explanation good on a scale from 1 to 10? You could have them elaborate on what they thought might be better or worse about an explanation. Or you could even just have them make ratings like of similarity or dissimilarity. So it's not very common to ask for these kinds of ratings, let's say in a MOOC or online. And I think it could be because often, if you just ask this question at random 1 to 10 rating, people may not give informative answers. But if you sort of use the kind of assessments that psychologists have really honed down on for understanding things like what concepts people think are similar, or people's ability to predict when they make errors. I think there's some really useful information that you can get out of this. And what's even better is you're getting information about what students think, and you're helping them learn at the same time. The act of kind of comparing what they generated to what someone else generated could be really powerful. Or there's good reason to think it'd be really powerful for learning. Another thing that would fit in really well here is that there's work by people at Khan Academy like Carolyn Rose and David Adamson. And what they've got is they found a way to kind of leverage the minimum amount of AIU you can get into a web-based system to get lots of student learning. And so the idea here is that when people might type in something like this, like explain why you think that's correct, they get channeled into they're sort of placed in a small chat room with a couple of the students. So then this is not embedded in the context of necessarily a Khan Academy exercise, but it's embedded in the context of trying to solve a problem together. And so someone has to provide an explanation. And then the chatbot can then say things like, well, John, what do you think about that person's explanation? How would you say it in your own words? Do you disagree? And so these are simple questions you can ask people, but they've been shown to have a really powerful effect on students' learning. These sort of term for this cluster strategies like accountable talk moves. And the idea is that by getting people to really think about what they're saying and how it differs from other people's ideas, you can get a lot of learning. And once you have that chat bot in there, it can also act as sort of instructor or tutor, but one that doesn't need a lot of attention, a lot of time, because students will often carry a lot of conversation themselves. And the key thing is just doing things like adding prompts to keep it going, or matching a student's explanation to something else in its database, and then not saying, and just asking the student, is this what you meant? And so it's a great way that very simple technology, you can give an answer, and your answer is probably not going to be totally right because NLP isn't there. But then actually the students having a learning experience because they're now trying to sort of correct what you said and sort of put exactly what they were trying to get across. I think it's a really exciting line of work to look at. Okay. So in terms of thinking about the benefits of explanation, I think it's a great way to sort of have instructor guidance because you can ask people questions that guide how they're thinking, while at the same time having learners generate information or generate knowledge, so they're actually constructing it. It's also, especially in online courses, useful because you can do learning without any feedback. So you might have to do things to get people to actually generate explanations, but it's a great way of actually maximizing learning without necessarily having, even if you don't have the resources to give people individualized feedback. And again, it's really key because, as you sort of mentioned, transfer is really challenging for people. So the fact that explanations help them understand these abstract principles can have a very powerful effect on their learning. So in terms of thinking of what you can, do you have a question? Oh, that's a planned study. That's a planned study, yeah. So, since you were talking about saving resources. Yeah, and I think it'd be really exciting to look at. The question was, did we find effects of having them grade other people's explanations? I was just saying that that's a planned study. Because we can manipulate tons of things in the lab and using software of our own, but when we have to deal with a platform that has its constraints, unfortunately, it takes a lot of adaptation. Just on a side point, actually, one way I think that sort of research psychologists can be really relevant to people who are actually doing sort of practical work, like in edX and Coursera and Khan Academy, is they sort of have a lot of constraints in terms of the system they have to build has to scale, getting things done. But actually, I think something like a sandboxing addition to any of those platforms will be really useful. For example, there's like 50, I mean, literally 50 softwares that don't require programming experience. You can author and experiment really quickly. It won't be as beautiful or as glossy as maybe you think Khan Academy is perfected, but it'd be a great way to test out very quickly and cheaply lots of different strategies for learning. And then once you figure out which ones seem to work really well for learners, that's what you put your development time into actually investing in. For example, with Google's Open Course Builder, maybe there's functionality you're thinking of implementing. Well, before doing that, you could sort of try and add an addition to a power searching course where some people will opt in to sort of take in a different software, and then we can manipulate tons of things in terms of the questions they're asked or the examples they see or the format of video presentation. And then when you see which ones are really effective, that's some functionality you could then build into the platform. Okay. So in terms of thinking what people can do after learning, after sort of study is done that actually has a huge effect on learning, I think the really interesting idea here is to use assessments as instructional tools. So normally we think of a test as just being to measure what someone's done. You know, it's sort of like an inconvenience. It's sort of taking away time from learning. And actually, you know, at McKinsey, for example, especially when they do training of soft skills, the instructional designers complain that when they're spending 20% of time actually testing people on this, and it actually seemed like it was a waste of time because that was less instruction people were getting. I think that's sort of something that maybe needs to be rethought in some ways because there's now really good evidence that actually testing people can have a really powerful effect on what they learn. So if you think of the traditional model where you do lesson 1, lesson 2, and lesson 3, and then maybe you do them again, you sort of drop some more information into the bucket, versus actually after each of those, you actually add an assessment. So there's actually tons of reasons testing can help learning. For example, if it gives you feedback, if it makes you more motivated to study. But I'm actually going to talk about the effects of testing that are only due to taking the test. So there's no feedback involved and you're not allowed to restudy. So the idea is there's something like mnemonic or there's something cognitive about having to generate the information yourself. Even though you get no new information and you don't study, and on a test you normally generate much less than what was actually in the actual lesson. So this is referred to as the testing effect. As you can imagine, if you give a learner the option to study something once, and then following that they had the option of studying it again, versus they had the option of studying it and then taking a test. Most learners would opt for this first one, and in fact, there's good data that they do. And in a way, it's sort of strange to think that taking a test would be helpful because you can't recall the 200 facts in the video, you can only recall a subset of them. But what's actually been found is, if you look at immediate testing, so let's say you do the 2 videos, you do a video and a test, and then you, let's say, do one more test short after. You actually don't find so much of a difference, or you find a slight advantage for spending extra time studying. But if you wait an hour, a few days, or weeks, what you actually find is that studying twice is definitely much worse than studying and being tested. In fact, the most recent paper in Science found that you could have people study 4 times in a row, and it wasn't as good as studying and then testing. So the key thing that's going on here is thinking about the sort of retrieval stage of learning, where it's not just about having information in your mind, it's actually being able to get at it. And when you do a test, you're sort of forced to form the cues or the retrieval pathways, the connections that will help you get back at information. What's interesting is in all these studies, even though they were doing worse in the study condition, they claimed that they were doing better and they expected their performance to be higher. Oh, another really interesting finding actually is, that I think has gotten less attention, but it's very powerful, is what's called the mixing effect. So let's say you have questions of type A, B, and C. Lessons A, B, and C. It's natural to put the assessments for A, whatever 3 exercises you have right afterwards, and so on for B and C. But the idea behind the mixing effect is don't make new exercises or do anything different, but just scramble the order. So after you learn A, you get 1 question on A. After you learn B, you get a question B, a question on A, and a question on B. And then when you finally finish it out on C, you get a mix of all of them. And so this is especially dramatic because you haven't increased how much exercises you have to make. Learners do terribly when they're doing this and they think they're doing really badly, but it has profound effects on their ability to actually generalize. Because the idea is that when you sort of do an exercise and then move straight into having a bunch of questions, it's really easy to sort of know which principle applies. when you mix them together, it's really necessary for them to figure out what the correct principles are and where they apply. And so even though they do much worse in the learning stage, they do far better in generalizing. And this is something you can easily do in a textbook, right? Take all the exercises and start mixing them around. Yeah. Let me think a second. So there's no study I can think of that's done that, even though there might be one out there. But I hope I should look for that because that would definitely be, as you said, a great point. Yeah. Yeah, that's a really good point, actually. Yeah. So I'll check the person. So this is the person who's the expert in mixing effects. So I'll take a look at the paper and see if he's done that. But that's true. That would work really well. And it's not something I think that would necessarily be obvious from this perspective. But if you put together the problem-based learning work, then it does make a lot of sense. So, basically, I think what's sort of really exciting about this work is that basically when you have online education, you kind of have a real world lab. We sort of have to be in the lab as psychologists because you need control and you have to be able to measure what people are doing. But now that people have moved online, you've got a real world environment that's exactly like a lab context. You can do experiments, randomized assignments, precisely deliver and control, and you can have really quantitative measures of learning that are automatically connected. And so I hope that in the future, what that means is that you get a lot more cognitive scientists and experimental psychologists actually working directly in online education platforms, whereas normally it's incredibly difficult to do education research. You can't have a teacher randomly assign instruction to different students. They just can't do it, whereas you can have two different videos show up. What's also really nice then is that we're doing research in a context with really rapid ecological validity. And you're actually doing research on a product where when you're done with your theoretical research, it's actually been improved. It's better for learning. And so what you can have is a lot of evidence-based decisions. You can take that product and deliver it directly to someone. So there's perfect fidelity to treatment. Whereas a lot of research conclusions, even if they work really well when the research is carried out, it's hard to disseminate it because the way someone else implements it isn't guaranteed to be true to that. There's great scalability because you've got these implemented in an online system. And especially you've got the knowledge really wrapped up in the precise things that the researchers decided to ask. And of course, iterative improvement where it's constantly getting better. So given that there are all these methods for sort of improving learning, I'm coming towards the end, so I'm going to sort of touch on these things really quickly. But the idea is if you've got these ways of teaching a concept that seem to be effective, well, what concepts do you want to teach that are going to have the maximum effect? And any kind of concept that improves people's future learning is a good candidate. So quickly, I'll go through motivation, learning strategies, and online search. And so in terms of increasing motivation, the idea here is that one really powerful way to motivate people is actually by targeting their beliefs about intelligence. So do you agree, for example, that your intelligence is something very basic about you that you can't change very much? Or do you think no matter how much intelligence you have, you can always change it quite a bit? And so Carol Dweck characterized that as being a fixed theory versus a malleable theory of intelligence. And it's pretty shocking what this predicts in terms of people who start off with equal IQs will sort of diverge because people with a fixed theory avoid taking hard problems. People with a malleable theory always ask questions. They're happy for challenges. They don't think it means something negative about them. And so what are the effects of actually teaching people a malleable theory? And so this is work that's done by PERTS, the Project for Education Research to Scales at Stanford, as Dave Paunesco and Carissa. Actually, Carissa's right here. She just wanted to sit in. And so what they did is try and distill down these insights into a single lesson where people would be taught that the brain's malleable. Then they would have some questions and make them think about how it applies to their life. And you could contrast that to a control condition where the same lesson would teach people about the brain, but not necessarily emphasize the idea that your brain changes every time you learn a new fact and the intelligence is constantly being improved. Do exercises, and then try and take some measurements of what people's mindsets are. And so this is great in terms of actually being able to see what effect this has on students. And they've set up this whole system for actually running it in high schools and middle schools and so on. So it's got all those great features of a real-world lab that I mentioned. But in addition to asking about mindset, they also just collect the students' grades. And normally, I wouldn't collect a measure as ambitious as grades because it's so hard to impact something that has so many variables feeding into it. And there's a lot that goes on. But actually, what they found in this randomized controlled trial is that just 2 lessons of about 45 minutes actually boosted students' GPA. Now, you might think grades are not the best measure of of things, but if someone knows how to change grades, they really understand something really deep about the psychological structure of what students are doing. And you can imagine these kinds of effects applying in all kinds of contexts. For example, in a workplace, in terms of changing people's beliefs about hard work or about what it means to get negative feedback. And so in terms of how I was thinking it'd be good to bring cognitive and social psychology together in this way is to sort of apply some of these principles like preparatory questions during the actual learning of the material to have explanations, and after sort of questions that repeatedly have them apply the concept. And so with Dave and Carissa, I developed some additional measures of how people might apply mindsets. And we'd like to create video versions for MOOCs and Khan Academy and that you could sort of give to someone, but we haven't got to that yet. But what I've done is taken those cognitive principles and applied them to the text they had, and sort of try and take this simple idea of a mindset, but teach people it in a way that they're more likely to remember it and apply it to situations in their everyday life. And so that's actually running now, but in some of the lab studies at least, it is having an effect where even if mindset is better than the control for getting people to believe in a growth mindset and make judgments about other people that are consistent with a malleable theory, the effect of the additional cognitive manipulations is sort of increasing that further. Well, that's part of the work, but we have fingers crossed that it's going to turn out successfully, and especially if it impacts grades. Another thing that is really interesting is there's so many ways this mindset idea can be implemented into courses. For example, changing feedback in exercises. It's natural to tell someone who does well that they did great. And it's even better to tell them they're smart. But the problem is when you tell someone that they're smart, you're emphasizing something internal and fixed about them, a quality. And so there's actually work showing that that can actually undermine children's abilities. By praising them for their intelligence, they can actually start to become very resistant to trying things out or being worried about showing that they're dumb. Whereas praising children for their effort, or praising them for the way they've set up a problem or approached something, or trying to find out more, is actually a lot more effective in the long run. And so you can imagine in Khan Academy exercises, in workplace evaluations, sort of trying to frame things from the perspective of improving or people's ability to be malleable could have a really powerful effect on learning. Okay. And so just quickly to go through, I'll just skip over these. So basically, I'd like to apply the same concept to learning strategies. And so the idea here is to integrate work not just from cognitive psychology, but also ideas about mindset and habit and behavior change, which is its own separate literature, to sort of get people to stop thinking about learning in terms of memorizing facts, but actually in terms of understanding, and in particular that what it means to learn a concept is to be able to understand it, to be able to teach it to someone else. So the idea would be within a MOOC where they collect grades automatically. It's a great situation to introduce training videos on learning strategies. Like whenever you're studying something, imagine you're going to be teaching it to someone. Or when you finish something, imagine if you had to explain what you learned to someone else, and have technology that can prompt people to do this, and then see if it actually does have an effect on final grades. And MOOCs provide a great way to actually do that data, that kind of longitudinal study that you just couldn't do before. A MOOC is a massive open online course. So at Coursera and Google Power Search, you have like 20,000 people and you teach a course. Okay, and online search, I guess you guys are all pretty much on board with online search being important. But actually, I think everyone knows it's kind of good to be able to search, but often, we think of it as just like a tool, like it's for something like fishing versus like a toolkit for problem solving. And online search, I think, is powerful for teaching because if a student has problems with a math problem and they're just in the habit or they have the skills to be able to find resources on the internet, they can find a site that's better for them than maybe their current textbook. They can find a site that offers free tutoring. If they ever later on in life need to solve a similar problem, they can go online and find those resources. And so I think online education that teaches students better search skills, or especially to search for knowledge as opposed to just being able to find product reviews online, could be really powerful in terms of learning. The fact that there's Google Scholar instantly means that if I hear a medical claim and I don't know if it's true, I can go and look on Google Scholar and just see what turns up. I may not understand the exact details of the journal, but if I find no journal article relevant to it, it tells me a lot. So these kind of strategies could actually be a great way to improve scientific literacy. Even, of course, being able to pursue sort of areas that are not under your current interest is also a great power of getting students in the habit of online search, where then you're allowing it to be a bit more independently driven if they want to learn about a topic that wasn't covered. And you can even imagine using online search to do things like, what are good learning strategies? Or how can I improve my grades. We don't think to go and Google that online, but it's amazing if what you will find on Google these days. So in terms of just, okay, I'm over, but the one point I'd make is cognitive science doesn't just have to be used for instructional design. I think it really interfaces nicely with the machine learning and AI work that people want to do. Right now, we've got like binary answers or multiple choice questions. And it's true it's big data in that it's on the order of, tons of information. But if you have a narrow bandwidth, you just can't get that much out of it. And so I think subtle changes to these things can make a big difference in what we can get out of machine learning and data mining. For example, having people rate the plausibility of each of 4 multiple choice questions converts our binary score into 4 numbers that each correspond to a different kind of concept. Just including those as standard practice. For example, you just have them rate 1 to 7 and stars, something everyone understands. Having people predict their accuracy is also a really powerful thing because there was a study that administered an SAT to students and then saw how it correlated with their later performance undergrad. And the SAT correlated with performance, but it didn't correlate with as well as how accurate students were in predicting which questions they got wrong and which they got right. So this study had you do an SAT question and say, how likely are you to get that right? And the fact that you were good at judging what you were getting wrong or right was a much better predictor of undergrad success than actually the SAT itself. And so if you're looking for an individual difference in learners, that would be a great one, how good they are at understanding gaps in their own knowledge. Rating similarity, it seems very simple, but that's again something that's just been shown across tons of studies to reveal something really deep about people's minds. And I think also grading explanations. So again, that'd be a much richer data set than is currently available for actually understanding what's going on. And that's where you might sort of see like big data turn into the best data you can get. So let's say I give you 2 concepts, and I say, well, how similar is this mathematical concept to this mathematical concept? Or 2 explanations, and I say, well, how similar are these? How different? And that's actually a really powerful way of like getting at what people think or believe. Okay, and I'll sort of happy to talk about this more, but I've tried to put together resources that have been useful for me on a website in terms of citations. And if you're really interested in improving education, this is a great book in education policy that sort of looked at all the systems across the world and tried to see what insights that they have for US education. And I think especially online education is different. Obviously, there's a lot that's already known. So we could benefit from a lot of that. All right, thank you. Do people have any questions? Yeah. So there are a bunch of, so the question was, I was talking about subjects to explain were drawing on knowledge they already had, and how did I measure it? There are many different ways people take to it. Mostly past studies, like you said, administered a pretest. The way I did it was actually I manipulated knowledge experimentally. So they explained or didn't, and then as another experimental factor, I gave them extra training or I didn't. And so that's a way you can know exactly kind of what they've been learning.
One of the benefits of getting people to explain is that you can have learning without feedback.
Yeah.
But you mentioned that explanations could be harmful for those people who didn't have the idea of what you were thinking, have a way of learning without feedback.
Yeah. So I think, yeah, that's a really good point. I think that's why I try to sort of look at seeing, well, what exactly is effective explanation? Because then once we have a bit of a better handle on what explaining is doing, like if it's driving people towards principles, then we have a better sense of, okay, it's not a good idea to ask this person to explain at this point in time. We should wait to ask them to explain when they have more knowledge. Or it would be a bad idea to ask them to explain why these 2 problems are correct, because that might lead them to a sort of like a local generalization that only applies to those 2 math problems. For example, with the statistics example, it's pretty reasonable to say people with higher scores would be ranked more highly, but that's just accounting for the observations you've seen so far. It won't hold in the general case. So I think features like that in terms of how you set up the environment and which cases you ask people to explain would be important variables to look at. So I think then more research or using research that's already there would be useful for that. Another thing to keep in mind is actually that sometimes it can actually be helpful for people to produce a wrong explanation. And there's a paper that sort of suggests this and has some evidence from the coding they did, but it wasn't tested experimentally, which is that once you produce a misconception and sort of codified it, it's then a lot easier to recognize it. Because then, you're not just sort of implicitly thinking through things, you've actually sort of made a statement like, I think that person's ranked high because they got a higher grade. And then when you see data that actually goes against that, you can then revise your belief. And for example, that's how a lot of children's learning might work, where you could say, my hypothesis space is flat, and I'm not going to do something until I know a lot of data. Or you could say, I'm going to try a lot of things out, and then just be really open to revising them quickly. Yeah. So on that sort of resource page, I have some references that be relevant. But you can email me, and I'll let you know some more. But Eric Mazur, who's a physicist at Harvard, has sort of pushed this idea of a sort of it's not flipped classroom, but where every class actually is structured kind of around questions in the sense that he'll start a lecture. After 5 minutes, he'll put a question on the board, and people will start discussing it. They'll turn to each other and they'll say what they think, then they'll argue for, they'll argue against, then they'll get back. Then he'll pass around and talk with them, and they'll get back together. And so I think that's got a lot of really good lessons in there. And also this idea of, I think I mentioned reciprocal teaching, trying to teach someone a concept and have them teach it back to you. And I think that in terms of online environments, what would be really powerful would be having people generate free responses, and then again, letting them sort of see other people's explanations and use those as a base for comparison. And so that's something where I think you can get people to be a lot more engaged, plus get the benefits of generating information, plus the benefits of things that are like the right answer. So that's why I'm really excited about sort of trying that out. A big thing that I think that people do now is because they think that they have to give someone an explanation, there are very few free responses. So a lot of the cognitive tutors, which are these adaptive programs, will actually give people a multiple choice list of explanations. And I think the simple manipulation of not having multiple choice, having a free response, and then putting the multiple choice can make a really big difference in terms of what people learn. You had a question, or?
We're running out of time.
Oh, okay.
And so I think if you have any further questions for Joseph, feel free to answer directly after the talk. But thank you again, Joseph, for coming.
Thanks for having me.